this is part 2 of the homework video guide for negative exponent rules. And just before we start, this is just a review of the two main concepts that were covered in the first homework video guide. And that is, when you have a negative power, you can write it as a fraction as 1 divided by the base with the positive exponent. And if you have a fraction with a base with a negative power, you can rewrite it as a base with a positive power. So those are the two main rules that we were using in part 1, the homework video guide. And now we will continue to solve a few more questions here. Starting with question number 8, so I need to simplify and write the answers with positive exponents. So when the bases are the same, and if you're multiplying, all you're really doing is you're adding the powers. All right, so this time you're adding 10 plus negative 5. All right, and if we simplify that, that'll be 10 to the power of positive 5. Okay, moving on with letter B. Once again, if the bases are the same, we are adding the powers. So, if the bases are the same and if we're dividing, we subtract the powers. So this will be m to the power of 5 minus 8. And this will be m to the power of negative 3. And when you have a negative exponent there, you can write that as 1 over the base, which is m to the positive power of 3. Moving on to letter C, this time we're multiplying, and if we're multiplying and if the bases are the same, we are adding the powers. So negative 1 plus negative 3. So this is b to the power of negative 1 minus 3, which is b to the power of negative 4. And when you have a negative power, that's just written as 1 over b to the power of positive 4. Okay, moving on to letter D here. If we are dividing, we are subtracting the powers. So this is going to be w to the power of 0 minus 5. And then we have this negative sign, which is just tagging along. And if we continue here, this will be negative w to the power of negative 5. And you can write that as negative 1 over w to the power of 5. Okay, so this minus sign is just tagging along the whole time. Okay, let's keep on moving along here. So the next set of questions that we're going on to is question number 9A. So I need to simplify and write the answer with a positive exponent. So very similar to question number 8. So once again, if the bases are the same and if you're multiplying, you are adding the powers. So this is a to the power of 8 plus negative 10. And if I continue here, this would be a to the power of negative 2. And when you have a negative power, you can write that as 1 over a to the power of positive 2. Okay, let's continue on with letter C now. Okay, let's start out with the numbers here. So 6 divided by 2 is going to be 3. So divide the numbers with the numbers. And then if you're dividing variables with the same base and different powers, then you are subtracting the powers. So this will be y to the power of negative 6 minus, and then negative 4. Okay, now we have 3, and then y, and then if I evaluate negative 6 minus negative 4, that's the same thing as negative 6 plus 4, which is equal to negative 2. So 3y to the power of negative 2. And if you want to write this with a positive power, you can write the 3, and then you can divide this by, and then y to the power of negative 2. You can put that on the denominator as y to the power of positive 2. And that's how you solve 9C. Okay, let's move on to 9E now. Okay, this one's not too bad because the variable x to the power of negative 2, that has the negative power here. So it turns out is that this negative 7, you can just write that on the numerator, and then on the denominator you can write the x with a positive power. So negative 7 divided by x to the power of 2. Okay, let's move on. This one's a little bit different because everything in the bracket is being raised to the power of negative 2. So if you want to work with that, you can write that as 1 divided by, and then bracket 7x to the power of positive 2. And then you have this negative sign which just tags along like that. So negative 1 over 7x all to the power 2. And if you continue to simplify this, I have a negative 1 divided by, and this part right here is 7x to the power 2. That's the same thing as 7x times 7x, which is 49x to the power of 2. So negative 1 over 49x to the power 2. Okay, letter G. Now we have everything in the bracket being raised to the power of -2. So when we have a negative exponent, we can write this as 1 divided by -7x all to the power of +2. Okay, so that -2 is going to be written as a +2 like that. All right, and now we can simplify this by writing this as 1 divided by, and then we have this -7x to the power of 2. So that's -7x times -7x, which is +49x squared. Okay, so basically we're just doing this calculation here, all right, which is -7 times -7 is 49, and x times x is x squared. Okay, so 1 over 49x to the power 2. Okay, let's move on to letter H here. Okay, so this is a good one here because there's a lot going on. Let's start dealing with the numerator first. Okay, so when I have that, with this negative power here, this -2, I can write this as 1 over -7x all to the power of +2. Okay, so this -2 is written as a +2 on the denominator there. Okay, so that's how you deal with the numerator. Okay, so this whole thing is really the numerator right there, and then I'm going to divide this by the denominator there. Okay, so there's a few ways where you can write this out. So this part right here is the x to the power -2. So you can write that as 1 over x to the power 2. And then you have the -7, which you can just put that in front as -7. Oops. I'm starting to realize I may have made this a little bit more complicated. So I have -7 times 1, which is just -7. So I just have just a -7 overall. So I can write my answer like that. And then we need to further simplify this, because what we're really doing here is, if I keep on writing this out, and I'll show you another quicker way of solving this problem in a bit, but let me just kind of take the long way approach to this. And when you have this division sign right here, you can write that as a division sign, and then you have your -7 over x squared. And if you go back to your fraction rules here from previous math classes, when you have a division sign, okay, so when you have a division sign like that, you can just kind of flip the fractions. So this would be x squared divided by -7, and then you're just multiplying that. Okay, so if we multiply this across, -1 times x squared, that's going to be positive x squared divided by, and then if I multiply all of this with this, I would get -7 times bracket -7x to the power of 2. Okay, so there's still quite a bit going on there, so let's see if we can continue simplifying this, because there's still a little bit more work to do, and I'll repeat this example again using a different method here. But what I realized here too is -7 to the -7x to the power 2, if I write that out, that's the same thing as 49x squared. And then you'll quickly realize that this x squared and that x squared will cancel out. And if you multiply -7 and 49 together, you will get 343. And then this minus sign takes along, and there's a 1 on the top. So 1 over -1 over -343, which is the same thing as -1 over 343. Okay, so that was actually like the longer way of solving that problem. That was good practice. But let me kind of repeat this problem, and let me just kind of show you a little quicker way to kind of maybe perhaps get to the right answer here. I would say this question, if you're very good at just kind of flipping your fractions or reciprocating your fractions, you can probably solve this question a little bit faster here. But what you can do in this particular question is you have to go back to rule number 2 here. So if I go back to the first part of this video here, one thing that you need to remember with rule number 2 is if you have a base with a negative power on the denominator, you can simply just move it to the top. All right, so this 1 right here is really on the bottom, right? So the numerator comes to the bottom, and the denominator comes to the top. Okay, so if you're comfortable with that rule, then you can actually solve that particular question slightly faster here. And let me just show you one more way of approaching 9h a little bit faster here. So for example, when I have this expression right here in yellow, since there's a negative power, all you can really do there is just move that to the bottom as -7x to the power of positive 2. Okay, that means this part is now all done because you moved that to the bottom. Okay, and now you have this part right here. That part you can move to the top as positive x to the power of 2. All right, that just moves to the top. But this negative 7, that's still on the bottom as just negative 7. Okay, and then as you can see, we actually get the same result from our previous question where I have x squared on the top. I have negative 7 tagging along, and then I have this negative 7x in blue to the power 2, which is going to be 49x squared. And then we get back to the same result where that and that cancel off. There's a negative coefficient there, so I'm going to put the negative sign out in front. 1 divided by, and then if you multiply 7 and 49, you get 343. So this method is a little bit faster if you understand how to kind of flip your fractions, and that could save you quite a bit of time when you have those kind of problems. Okay, good question there. Let's move on to question number 10 now. Simplify each expression, write the answer with positive exponents. Okay. All right, so let's start dealing with this particular expression right here. We have a negative exponent, so we can write that as 1 over negative 2a cubed to the power of positive 3, and then times that by 3a to the power of 12. Okay, that's step number 1. Okay, now we need to deal with this 3 and this a to the power 3, so that's going to be 1 over, that's going to be a to the power of 9. 3 times 3 is 9. And then you have negative 2 to the power of 3. Okay, so if I just kind of erase this now, think about that. We have a negative 2 to the power of 3. So that's negative 2 times negative 2 times negative 2, which is going to be negative 8. Okay, so remember, negative 2 to the power of 3 is equal to negative 8. Okay, and then we can multiply this by 3a to the power of 12. Okay, so the way we can kind of write this out now in a simplified manner is I can have a 3 here, a to the power of 12, and then I can divide this by negative 8, and then a to the power of 9. Okay, all right, so if the bases are the same, and if we're dividing, we can subtract the powers. So that will be a to the power of 12 minus 9, so 12 minus 9 is going to be 3, so a to the power of 3. And then I have my positive 3, all divided by my 8, and the negative sign can just tag along like that. Okay, so that negative sign right there is just that right there. Okay, I guess another way you can kind of write this answer is you can also write this as negative 3 over 8. And then you can have your a to the power of 3 tagging along as well. So both of these answers are mathematically the same thing. Okay, let's keep on moving along. Okay, let's move on to, I believe this is 10F. Okay, since we have a negative power there, I can put this all under a fraction here. So everything here will be on the denominator here. So negative 3, a to the 5, b to the negative 3, c to the 0, close bracket, and then we'll have a positive 2 there. Okay, and then from there on, we're just going to be distributing the 2 onwards here. So if I multiply this with this, let me just continue on here. This will be 1 over, this will be c to the power, well, 0 times 2 is going to be 0, and then 2 times negative 3 is going to be b to the negative 6, and then 2 times 5 is going to be a to the power of 10. And then finally, if I just erase all this, if you think about that, I just have my negative 3 to the power of 2, right? So negative 3 times negative 3 is going to be positive 9. Okay, so now I have this expression right here, and what I notice right now is there's a b to the power of negative 6. So since that has a negative power, I can move that to the numerator as b to the power of positive 6. The 9 remains. The a to the power of 10 remains, and c to the power of 0 is just 1. So if I had to fully simplify this, this is b to the power of 6 divided by 9, a to the power of 10. Okay, so there you go. There's your final answer for 10F. Okay, question number 11, simplify, write the final answer with positive exponents. Okay, great. We have a very good combination question here. So what we could do is we could try to simplify each fraction individually before we have to break things down. So for example, we can do 32 divided by 4. So 32 divided by 4 is going to be 8. Okay. Then I have a squared divided by a to the power negative 8. So that's the same thing as a to the power 2 subtract negative 8, which is just a to the power of 10. All right, so I have a to the power of 10 there. Okay. And then I have b to the power negative 4 divided by b to the power negative 2. So that mathematically, that's the same thing as b to the negative 4 minus bracket negative 2, which is b to the power negative 4 plus 2, which is b to the power negative 2. So I have b to the power negative 2. Okay. Now I'll put that in a bracket, because now I'm going to multiply that by the next fraction. And the next fraction here, there's not much I can really do here. I can write this as negative 8a to the power negative 2, and then divide that by negative 3b to the negative 3. Okay, so here we go. What can we do here? Well, we can do 8 times negative 8. So 8 times negative 8 is going to be a negative 64. Okay, now I have a to the power 10 times a to the power negative 2. That's going to be 10 minus 2, so that's going to be a to the power of 8. Okay, and then now we have some weird stuff going on. We have b to the power negative 2 and b to the power negative 3, right? So mathematically, that's the same thing as a b to the power negative 2 minus negative 3, which is b to the power negative 2 plus 3, which is b to the power of positive 1, which is just b. All right, so b would be on the numerator there. And finally, there's this negative 3, which is tagging along, so I can divide this all by negative 3. Okay, the last thing we can do here is have a negative 64 and a negative 3. So a negative number divided by a negative number is going to be a positive number. So 64 divided by 3 could be your coefficient. Then a to the power of 8 and b. So there is your answer for 11a. So it's a very good question there. Okay, let's move on to 11b now. Okay, so another good question here. So what I noticed right now is there's a 10. Okay, so we can write this with a 10 out in front. Okay, so here's step number 1. I noticed that there's a negative 3 here, right? A negative 3. So what we're going to do is we're going to take this, everything in the blue brackets here, since there's a negative, since that's being raised to the power negative 3, we can just bring that to the bottom as p to the power of 3 q squared r to the 0, and now we have a positive power 3. Okay, and on the denominator here there's a negative power there, so everything in the green bracket can now go on to the numerator, and we can have a positive power there. So what I mean by that is 8 p to the negative 3 q to the 5 r to the 3, and this will have a power of positive 2 now. Okay, so there you go. We were able to handle these two negative exponents right from the get-go by just flipping them, right? So that's what we have here. Okay, so what we do next now is we start dealing with these positive powers. So let's go backwards here, right? So that's going to be 3 times 2, which is r to the 6. All right, 2 times 5 is 10, so that's going to be q to the power of 10. And now I have 2 times negative 3, which is p to the power of negative 6. Okay, and then we have our 10, which is hanging around as a leading coefficient. Oh wait, sorry. I forgot that there was an 8 here, right? So 8 to the power 2 is going to be 64. 8 times 8 is 64. And then we still have this 10 hanging around, so I'll put the 10 just next to that. Okay, and now this is all being divided by is being divided by the denominator there, so I'll use a purple marker. So 3 times 0 is 0, so this is r to the power of 0. And then 3 times 2 is 6, so q to the power of 6. And then 3 times 3 is 9, which is p to the power of 9. Okay, so now we've got to simplify this now. All right, so another good question here. So let's go ahead and do this slowly here. So 10 times 64 is going to be 640. Okay, now I have, let me get my blue marker here. I got p to the power negative 6 and p to the power 9. So mathematically what that means is I have p to the power negative 6 minus 9, which is p to the power of negative 6 minus 9, which is p to the power of negative, so negative 6 minus 9 is going to be what, negative 15, I believe? Yeah, so negative 15. So I can write this as p to the power of negative 15. Okay. Now let's take a look at the q variable here. So q to the power 10 divided by q to the power 6. So that one's not too bad. That's just 10 minus 6, which is 4. So q to the power of 4. And then finally over here I have r to the 6 divided by r to the 0, which is 6 minus 0, which is 6. So I have r to the 6. Okay, so we're almost done here. This is looking pretty good. The only kind of problem I have here is this: there's a negative power there, so we can just move that to the bottom by writing this as 640 q to the 4 r to the 6 divided by p to the power of 15. Okay, and there's your final answer for question 11b. Okay, let's keep on going. I believe this is 11c here. Okay, let's see if we can do this particular question here. Okay, so right away I see there's a negative power there, so power negative 2, and I have a positive power there. So right away we can write this as, I'm going to take this whole expression right here and leave that on the numerator as negative 2 x squared y to the power of negative 8, z to the power of 12, all to the power of positive 3, and then we're going to divide this by everything in the green brackets, because the green brackets are being raised to the power of negative 2. So this is going to be a negative 2, x to the 5, y to the power of 3, z to the power of 8, close bracket, and then I have a positive 2. Okay, let's go ahead and start distributing this. So 3 times 12 is going to be 36. So I have, this is going to be z to the power of 36. Okay, and then 3 times negative 8 is going to be negative 24, so y to the power of negative 24. Okay, and then 3 times 2 is going to be 6, so x to the power of 6. Okay, and then I have, let me just kind of erase all this now. And if you look at this, I just have a negative 2 being raised to the power of 3, so that's negative 2 times negative 2 times negative 2, which is going to be negative 8. All divided by, okay, so 8 times 2 is z to the power of 16. 2 times 3 is y to the power of 6. And 2 times 5 is x to the power of 10. And then if I erase all this, I have negative 2 to the power of 2, which is negative 2 times negative 2, which is just 4. Alright, so this is a great multi-step kind of a problem here. So now I have negative 8 divided by 4, which is going to be negative 2. Okay, x to the power 6 divided by x to the power 10. So you should be pretty good at this. This is 6 minus 10, which is negative 4. Okay, and then y to the negative 24 divided by y to the power 6. So negative 24 minus 6 is going to be y to the negative 30. And finally over here I have z to the 36 divided by z to the 16. So 36 minus 16 is going to be 20. So this will be z to the power of 20. Okay, although this is looking fairly decent here, we have to remember we have to write everything with a positive power here. So if you have a negative exponent there, you just flip that to the bottom there. So this will be x to the 4 and y to the 30. Okay, so there you go. That's how you solve question 11C. A very good question, a very good multi-step level problem there. Okay, a few more questions to go. Question number 12 here. So there's a general rule for question number 12. So if you have a fraction with a negative power, then you can flip the fraction and have a positive power. Okay, so this isn't too bad. It's actually quite quick if you understand the rule here. So if you have a negative power, all you have to do is just flip the fraction. So this will be 3 over 2. So we flip it. So bottom becomes top and top becomes bottom. And then we have a positive 3. Okay, and now we have to evaluate this, right? So 3 to the power 3, that's going to be 27, right? 3 times 3 times 3 is 27. And then 2 to the power 3 is going to be 8. So 27 over 8. All right, let's move on to letter B now. Okay, so I have a negative power, but there's a fraction, so we flip it. So this will be 5 divided by 1 to the power of 2. And 5 divided by 1 is just 5. And 5 to the power 2 is going to be 25. So there we go, a very quick one there. Once again, I have a fraction to the power to a negative power, so we just flip the fraction as 5 over 8 to the power of 1, and 5 to the power 8 over 1 is just 5 over 8. Okay, so another quick one there. All right, let's flip the fraction here. This will be 2 over 3 to the power of positive 4, and now let's evaluate this. 2 to the power 4 is going to be 16, and 3 to the power 4 is going to be 81. So 3 times 3 times 3 times 3 is 81. So 16 over 81 there. Okay, that's a quick one there. Okay, let's go to number 13 now. So now we have some variables here. So if a fraction to the negative power, we flip the fraction. This is a d over c to the power of positive 3. And if we had to distribute the 3 into the brackets, this would be d to the power of 3 over c to the power of 3. Okay, next one here, we flip the fraction. So 4 divided by x, we flipped it to the power of positive 3. 4 to the power 3 is going to be 64. So 4 times 4 times 4 is 64. And x to the power 3 is just x to the power 3, right? So this x is being raised to the power 3. Okay, we have another negative power here. So let's flip the fraction on the inside. So r to the power 4 divided by p to the power 2. All to the power of 3 there. Okay, this isn't bad. We just multiply the powers now. This is r to the power 12 divided by 2 times 3, which is 6, which is p to the power 6. All right, so r to the power 12 divided by p to the power 6. Next one here, let's flip the fraction. So this is b to the power negative 5 divided by a to the power negative 2. And then we can change this negative 3 to a positive 3. Now this is a good question because now you have a negative power and negative power. So what you do now is now you flip it one more time as a to the power of 2 divided by b to the power of 5. And then we still have a positive 3 there. Okay, so here we go. 2 times 3 is 6, so a to the power of 6 divided by 5 times 3, which is 15, which is b to the power of 15. So that's a very good question as well. Okay, moving on. Okay, let's go on to a few more challenging questions, some multi-step problems here. Okay, so I have a negative power here, so we can flip the fraction. So this will be a 6y to the power negative 8 divided by negative 12 x to the power negative 3 all to the power of 1. Okay, and then I notice that these variables have negative powers, so you can flip those as well. So this will be 6, and now this thing, x to the power negative 3, goes to the top as x to the positive 3 divided by negative 12, and then we have this y to the negative 8 will be y to the power positive 8. All right, that's looking pretty good. And then finally we can do 6 divided by negative 12, which is 1 over negative 2, and then we have your x cubed divided by y to the power of 8. And although that's technically correct, you can rewrite this as just x to the power 3 divided by 2y to the power of 8, and then the minus sign can just tag along. Okay, so that's another way where you could write that particular question there. Okay, good. These are all good questions here. And that concludes this homework video guide. Actually, no, we have one more here. So we got one more here. We got F here now, right? 13F is the last question here. Okay. Last question here. Okay, I see that we have a negative 2 there. So once again, we can flip the inside fractions there. So we have negative 8 x to the power of negative 1 y to the 5 all divided by 12 x cubed y to the power of negative 1, and all of this is now being raised to the power of positive 2. All right, so that's step number 1. Okay, what I see next is that there's a negative power here and a negative power there, so we can also flip those variables. So I have my negative 8. Okay, let me start out with this y to the power of negative 1. So if that gets flipped to the top, we have y to the power of positive 1, and then I have y to the 5, all divided by 12, and then this x to the power negative 1 goes on the bottom as x to the power positive 1, and then I have my x to the power of 3, and this is all being raised to the power of 2. Okay, let's keep on going here. So if I combine these two y variables here, That's going to be, well, we have a negative 8 there, and then I have y to the power of 6, so 1 plus 5 is 6, all divided by 12. And then if I combine the x's there, 1 plus 3 is x to the 4. Okay. All right, so I cleaned up the inside as much as possible, and then I have this outside 2, right? So this outside 2 is still hanging around. Okay, let's go ahead and now distribute the power there. So this is going to be y to the power of 12. And then I have negative 8 to the power of 2, which is negative 8 times negative 8, which is 64. All divided by, okay, now I have x to the 4 and the 2, so that distributes there. So 4 times 2 is 8, which is x to the 8. And now I also have 2 and a 12 and a 2, right? So there's a 12 and a 2. So 12 to the power of 2 is 144. Okay, so there we go. We're almost done there. So 64 divided by 144. If we go ahead and just kind of reduce this fraction here, there's one more thing we have to do. So 64 divided by 144. Keep on reducing the fractions. You'll get 4 over 9. And then we have y to the 12 and x to the 8. Okay, so there's your final answer there for that particular problem. And now that finally concludes the homework video.